Welcome back to another video on our channel. Today we will be discussing momentum and collisions. To begin, what is momentum? Momentum refers to the quantity of motion that an object has. Momentum is the product of the object's mass times its velocity. Any object that is in motion has a momentum. An example of momentum would be a paintball flying through the air. If anything has a mass and a velocity, then it has a momentum. One thing we have to explain before we start the demonstrations is the difference between inelastic collisions and elastic collisions. Momentum is always conserved in every type of collision, but in elastic collisions, kinetic energy is also conserved. Usually in an elastic collision, the objects bounce off of each other, but in an inelastic collision, the objects usually stick together. The first demonstration we have today is an inelastic collision. We will be shooting a wooden target that is stationary with a paintball gun. We know the mass of the target as well as the paintball, and we know the velocity of the paintball as well as the velocity of the target because it is stationary, which makes it 0. The second demonstration we have here today is an elastic collision. We have two carts that are traveling along a track with marked measurements, which will assist us in calculating the final values. Cart 1 traveled 32 centimeters in 0.87 seconds before it struck Cart 2, which traveled 48 centimeters in 1.39 seconds. Both of these carts weigh 512 grams, or 0.512 kilograms. Using the carts' displacements and their times, we can calculate their velocities. Cart 1 struck Cart 2 with the velocity of 0.3678 meters per second, and Cart 2 left the point of impact with a velocity of 0.3953 meters per second. Now it is important to note here, in an ideal world, Cart 2 would leave with the same velocity it was struck with, since these two carts have the exact same mass and it's an elastic collision. The only reason their velocities are slightly different is because of human error in measurement of their times, as well as friction. The equation for deriving the final velocity in an elastic collision is V1 final equals m1 minus m2 divided by m1 plus m2 times V1 initial plus 2m2 divided by m1 plus m2 times V2 initial. But we can disregard this second term because mass 2 was at rest, which makes the whole term 0. Now you'll find here that since the two masses are equal, m1 minus m2 equals 0, which also makes the first term 0. And you will see that mass 1 stops after the collision, which is what happens every time when two equal masses collide elastically. The next step is to find the final velocity of mass 2. For this, we will use the equation V2F equals 2m1 divided by m1 plus m2 times V1 initial plus m2 minus m1 divided by m1 plus m2 times V2 initial. But again, we can disregard the second term because mass 2 was at rest when the collision occurred. So you are left with V2F equals 2m1 over m1 plus m2 times V1 initial. And when you plug in numbers, that becomes V1F equals 0.512 plus 0.512 divided by 0.512 plus 0.512, which makes the whole term 1, times V1 initial, which is 0.3678 meters per second. So you'll find that V2 final is equal to V1 initial since these two masses are the same. Now we actually got V2 final to be 0.3953 meters per second when we timed it, but again, like previously stated, that was just due to human error and friction. So in conclusion, today we discussed momentum, elastic collisions, inelastic collisions, and the methods to derive the final velocities in both of these situations. As always, thank you guys very much for watching. Don't forget to like, comment, and subscribe. And always remember, even a monkey can plug in numbers. Always do your algebra first, then it becomes a simple plug and chug.